what you are going to have is the concept of dielectric constant. Dielectric constant. Dielectric constant. Other name of dielectric constant is relative permittivity. Okay, so this is the next topic that you are going to learn, dielectric constant or relative permittivity. It relates with a particular medium. So, particular medium of the relate. Let us see how to define this dielectric constant or relative permittivity. For the first time, let us take two medium ani lower see. One is vacuum. Suppose this is vacuum. Then this is any other medium. Atopa medium ama heta lower see. Vacuum see my absolute permittivity the kind of denote away epsilon naught na denote away. Epsilon naught is the absolute permittivity of vacuum. Aduga medium see magi kanona absolute permittivity do na epsilon na denote or say. Then we are going to define the dielectric constant or relative permittivity of this medium. For this particular medium, we are going to define dielectric constant. Then, what you are supposed to do is, you take two charges here, Q1 and Q2, separated by distance R. Separated by distance R. Then you take the same two charges, Q1 and Q2, at the same distance of separation R. What is the difference? In the first case, the two charges are kept in vacuum. In the second case, you are keeping the charges in another medium, for which you are going to define the dielectric constant. Let us try to write down the force. Force between the two charges when kept in vacuum, let us say F naught. This is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. So this F naught is the force between Q1 and Q2 separated by distance R, which are kept in vacuum. Then if the same two charges are kept in the medium, then in the medium where you are going to define the dielectric constant, then the force should be how much then? Force is F equal to 1 by 4 pi epsilon Q1 Q2 divided by R square. The same two charges kept at the same distance of separation. This should be the condition. Charge anido even the distance of separation this is the condition to be satisfied. Then you will define the dielectric constant K, capital K, of the medium is the ratio of this F naught divided by F. Then dielectric constant of a medium define the way dielectric constant of a medium, it is equal to the ratio of force between two charges in vacuum, this F naught, to the force between the same two charges the same two charges kept at the same distance of separation in that medium. Dielectric constant of a medium is defined as the ratio of force between two charges in vacuum the F naught to the force between the same two charges kept at the same distance of separation in that medium. So let me write it down here again. The dielectric constant of a medium Karmaina define tawre haba. This K or another say epsilon R na so denote away relative permittivity. This is the ratio of F naught by F ni. This is the very definition which is to be learned just at the beginning. Then asidagi nang imagine toro F naught to C sinjilani, F ki mode C sinjilani, kari common oire Q1 Q2 Q2 katha nagrani ko R square katha nagrani aduga kai lemor 1/4 by 1/4 by lemorani aduga asida katha nagba yaba katha nagraga ida epsilon no sino makha da layani badaka na kayani epsilon layani ko. So you have the definite proper formula for dielectric constant of a medium. Either you can define in terms of force. Previously in high heat minor not there, you can define it as ratio of absolute permittivity of the medium to the absolute permittivity of free space natural vacuum. So you have two definitions of dielectric constant of a medium. One is dielectric constant in terms of force. One is dielectric constant in terms of absolute permittivity. So any super definition is the live amine high tare dielectric constant of a medium is equal to the ratio of absolute permittivity of the medium to absolute permittivity of free space. This is one definition. And the previous definition was dielectric constant of a medium is equal to the force between two charges when kept in vacuum to the force between the same two charges kept at the same distance of separation in that medium. So this dielectric constant value, it depends on the nature of the medium. Medium different oibing matung ina sige dielectric constant is different oigani for air medium ki oiba taragadi magi k value se this k value is approximately equal to 1 oineba ko aru karigumba for vacuum oiba taragadi for vacuum oiba taragadi k value se exactly equal to 1 dani. That is because epsilon naught by epsilon naught la hydra kan vacuum ki putok taragadi k is epsilon naught by epsilon naught la bi 1 and is obviously 1 tha. Well, that's why for vacuum it is written as 1. Here again approximately equal to 1, if either it may be less than 1. Well, for water medium and the value of K is approximately 81. The value of K for water is quite a large one. And for glass medium, this K value varies somewhere from 3 to 5 or 6. Why for glass ki di we variety you know have kanda depending on the nature of the glass makal mayamam like there will arise different values of dielectric constant of the medium. So let me sum it up again. Dielectric constant it is a ratio of absolute permittivity of the medium to the absolute permittivity of free space. From here, if you want to find epsilon, then this will be how much? K times of epsilon naught. So this is what we are going to use over and over again in the following classes.